So this was a class test which was related to topic the physical quantities, motion, mass, weight, and density, and the space physics. So in the first question, a student has a measuring cylinder containing water and also has a balance. Which of these could she use to find the volume of a small metal sphere? She has no other apparatus. So if you want to measure the volume, so to measure the volume, if we have a regular object, we can use a formula. But we have only a measuring cylinder. So a measuring cylinder which is filled with water, we can use it to record the volume using a displacement method, like fill the measuring cylinder with liquid and then add an object. How much the volume changes, that will be the volume of the object. So we'll take a measuring cylinder. Why not balance? Because balance is not used to measure the volume. The balance is used to measure the mass of an object. So we'll take a measuring cylinder, fill it with the liquid. Here, in this case, we'll fill it with water. And then we'll add an object. The volume will change. How much the volume changes? The change in the volume is actually equals to the volume of an object. The diagram shows a solid objects on a flat surface. The two forces are acting. What is the resultant force? A 4 Newton towards right and a 3 Newton towards left. When two forces are acting in opposite direction, to find the resultant, we subtract them. So it will be 4 minus 3, which is equals to 1 Newton. And which direction will have a resultant? The direction of a greater force. So that will be towards the right hand side. That's why B will be the right answer here. Which row contain one scalar and one vector quantity? So energy is a scalar and velocity is a vector quantity. So that's why A should be the right answer for this. What about the other option? Mass is scalar, time is also scalar, momentum is vector, weight is also a vector, distance is scalar, temperature is also scalar. So we want one quantity to be scalar and the other one to be vector. The table gives the data about the four liquids. None of the liquid mixes with any other. All liquids are put in the same container and settle to form four separate layers. Which statement is correct? So for this, what we have to do, we have to work out the density. Density is mass over volume, so 10 divided by 10. So density of the first one will be 1. The second one, like liquid W, the density is 1. For the density of the liquid X, it will be mass, which is 20 divided by 15. That will be
1.3.
so 1.33. And then it will the other one, it is 30 divided by 50,
0.7.
0.6. And then we have 40 divided by 50, 0.8.
0.8.
Yeah. So if we mix them together, if we add, so the most dense will be there at the bottom. So means which is the most dense X. So this first it will be X, then it will be W, then we'll have Z, and the least dense will be Y at the top. That will be the order of, because the difference of the density, the most dense will be there at the bottom and the least dense will be there at the top. So when we check the option, W form the layer, W forms the layer below X. So that is wrong. W is above X, so this statement is wrong. X form the top layer. X does not form the top layer. X form the bottom layer, like X is here. Y forms the bottom layer. Y forms the top layer. Z forms the layer below Y. So Z forms the layer below Y because Z is having like high density as compared to that of Y. So whenever we mix the liquids, the least dense will be there at the top and the most dense will be there at the bottom. That's why option D is the right answer. Is it clear, Usman?
Yes.
Yes, any doubt, Hamid?
No, sir, clear.
Okay. Then we have discussion is related to the space physics. The diagram shows a comet moving in elliptical orbit around the sun at which position greatest speed means it should be close to the sun to have because when it is closer to the sun it will have the least gravitational potential energy and the potential energy will be least and the kinetic energy will be maximum. Highest kinetic energy means it will move faster. So A at position A, the comet will move faster at any compared to any other positions. A nuclear reaction in the sun releases a large quantity of energy. Which statement about the process is correct? So surface of the sun or the stars, different stars, a nuclear fusion happen. So A and B are fission, so it means it's wrong. And what happened during a fusion? A lighter nuclei such as hydrogen turn into helium, or helium turn into other element. Helium does not produce hydrogen. Helium will, if helium fuse together, it will produce other elements such as carbon, oxygen, nitrogen. So D is the right answer that hydrogen produces helium. And our sun is a low mass star, so low mass star, and it's a main sequence as well. So hydrogen fusion happened. If it was a red giant, then the helium fusion, or a supernova, then helium fusion happened. Table gives the data about the 4 planets in our solar system. What are planets X and Y? So, and these are the temperatures are given. So if the temperatures are given using this temperature, we can identify if a planet is closer, because if a temperature is high temperature is there. So they give you the idea. The order is we have Mercury, Venus, Earth, then we have Mars, Jupiter, Saturn, Uranus, Neptune. So this is the order. Earth temperature of the Earth is given 15, and temperature of Uranus is given minus 195. So which is means it's cold, low temperature. So these two planets are given. So if these two planets are given a negative temperature is there means colder than Earth. So if they're colder than Earth means it should be further from the sun. So means it cannot be Mercury or Venus. So any option with Mercury and Venus is not correct. So C and D are totally wrong. Then we are left with option A or B. A is Mars. And if it was a Neptune, like now we have Mars and Saturn, two options are there, Mars and Neptune. So how we can identify if it was a Neptune, like if this planet, if we check B is the right option. So if planet was a Neptune, means the temperature of Uranus is minus 195. So temperature of the Neptune should be much lower than minus 195, like maybe minus 220, minus 250. But this temperature is minus 140. So it means this should be before Uranus. So it is minus 140 here. And then the Mars is, this one is a Mars. So A is like planet X is a Mars and the planet Y is Saturn. Why planet Y cannot be Neptune? Because this planet, because its temperature is minus 140. If it was a Neptune, then the temperature should be much lower than minus 195, like minus 220 or minus 250. Is it clear? So A is the right answer
Yes.
for this. Okay. Speed time graph. How far does the object travel at a constant speed? So first we have to find which region the speed is constant. So this region, the speed is constant. Like speed is not changing. So there's a speed time graph. So horizontal line means the constant speed. So what we have to do, we have to work out the area of this part only. So area of this part, this length is there starting from 5 and ending at 15. So this will be 10. This starting from 0 and ending at 5. So this is 5. So if we need, this will be 10 into 5. So that will make 50 meter. So B should be the right answer for this. Because they did not ask for the total distance, they only asked the distance travel at a constant speed. So it will be for the horizontal line. Which statement about a falling object accelerating close to the earth is correct? If the object is falling and it is accelerating, like there's a falling object and it is coming down, so we have to check which statement is correct. Weight of an object increase, that is wrong. Weight of an object will not change. Weight of an object and the force of air resistance of object are equal, but in opposite in direction. But in the question, they mention the object is accelerating. If this statement B will be correct, if they say the object is moving at a constant speed and it is not accelerating. If an object is falling at a constant speed, then the weight of an object and the air resistance will be equal. So statement B is valid if weight and air resistance are equal and the object move at a constant speed. But in the question, they mention the object is accelerating, like speed of an object is increasing. So if speed of an object is increasing, it means weight is more than the air resistance. And weight does not change. So weight of an object is constant, but the force of air resistance is increasing. Because why the force of air resistance increase? Because as the speed of an object increases, as the object is accelerating, air resistance increases. If an object is moving at a slower speed, the air resistance will be lower. If an object move at a high speed, the air resistance will increase as well. So air resistance depends on the speed of an object and the surface area. Smaller surface area, lower air resistance, smaller speed, lower air resistance. And the last one, weight of an object is less than the, this is valid if it is using a parachute. In that case, when using a parachute, in that the moment it open the parachute, then the air resistance will be more than the weight. So in this case, whenever object is falling, its weight does not change. Air resistance increases as the speed of an object is increasing. Question 10. An aircraft is moving at 60 meter per second in the direction of north. So we have the compass here, north, south, east, west. So an aircraft moving in the direction of the north, 60 meter per second. And a crosswind is there in the direction from east, like crosswind from the east start to blow. So the crosswind is there from the east visible, not towards east, from starts from east, so it means it is moving towards west with a speed of 13. So whenever two vectors are perpendicular, how to get the resultant? If we want to find the resultant, we always use the Pythagoras theorem. So it will be 13 square plus 60 square in a root. So whenever we want a resultant of the two vectors which are perpendicular, we will use a Pythagoras theorem, which is the square, like square of the two values, add them, like sum the square of the two values and then take the root. So 60 square plus 30 square, 13 square in a root, that will give us 61 meter per second. If two vectors are acting in the same direction, we will add them. If two vectors are acting in opposite direction, we subtract. And if two vectors are perpendicular, we use a Pythagoras theorem, or the sum of the square of the side, and then take a square root, we'll get the resultant. You can also use a scale diagram. That's also fine. This will also give the same result. But in a scale diagram, first you have to select like 1 meter per second equivalent to what? In MCQs, usually you have like 1 minute to do 1 minute or a bit more than that to solve one question. So it's better use a Pythagoras theorem when they're perpendicular, especially in MCQs. So it will save the time. Question 11, two rectangular blocks consist of different materials. 4 different methods are suggested to compare the two masses. So if you want to compare the masses of the two objects, compare the acceleration, look, if we compare the acceleration will be same. If we drop different objects of different masses, they will have the same acceleration. The acceleration due to gravity for both of them will be 9.8 meter per second square. So we cannot use this method to compare the mass, like which is heavy and which is lighter. Compare the value of a length, breadth, and height means compare their volume. So if we have because we want different methods to compare the masses. So using a length, width, and height, we can compare their volumes, but not the masses. We want to compare the mass like which is heavy and which is lighter. So measuring a volume does not give an indication about heavy or light. Hang each in turn from the same string and compare the extension. That is also one way. The one which produce a large extension means that will be heavier, and the one which produce a smaller extension that will be lighter. Place one in a right hand pan of a beam and one on the left. We can also use a beam balance, and we place one on the right, another one on the left. We place them in the balance and compare the position in the balance. Like if the balance tip towards right, it means the object which is on the right hand pan is heavier. If it tipped left, it means the object on the left hand pan is heavier. So 3 and 4 are the methods which can be used to identify whether they are lighter or heavier. So by comparing the free fall, because even a lighter object or a heavy object, they will have the same acceleration due to gravity 9.8. So we cannot compare. Same thing using the volume, we cannot compare whether they're heavy or lighter. So we can compare using a spring balance or by using a beam balance. So C is the right answer for this. Question 12, an object in a space probe above the earth weighs 3.5 Newton. The gravitational field strength is 7. The gravitational field strength of the earth is 9.8. What is the mass and the weight of an object on earth? Example. So this is the earth. The gravity of the earth is 9.8 Newton per kilogram. But there's an object in a space probe where the gravity is 7 Newton and the weight of an object is 3.5 Newtons. We need the mass. Mass does not change, like mass at this position and the mass at on the surface of earth, it will be same. So how to work out the mass? We have the formula that weight is mass times the gravity. So weight is 3.5, mass we don't know, and the gravity is 7. 7 is multiplied, other side will be divided. So 3.5 divided by 7 is a mass. So 3.5 divided by 7. So what is the mass here? The mass will be 0.5 kg. So if the mass is 0.5 kg in the space probe, then what will the mass on Earth? The mass will also be 0.5 kg because mass of an object does not change. It remains same. But weight changes depends on the gravity. So if you need the weight on the Earth, weight is mass times the gravity. So 0.5 multiplied by 9.8. So half of 9.8, which is 4.9 newtons. So weight of the object on the Earth is 4.9 newtons. Weight is 4.9 newtons and the mass is 0.5 kg. So first we work out the mass in the space probe, and that mass will be same as mass on Earth. And the weight will change as the gravity, it's different. Like gravity on the surface of the Earth is 9.8, so it will have a greater weight on the surface of the Earth as compared to a certain height above the Earth. Is it clear? Discussion?
Yes, sir.
Okay. How many quantities shown are scalar? So mass is a scalar, momentum is a vector, density is a scalar, energy is also a scalar. So three quantities are scalar here. A train on a straight track, the graph shows how the quantity y varies with the time. Which statement can be true? A train is stationary if y represent the distance from the last station. Like if it's a distance time graph and we have a horizontal line, which that means the train is stationary. So if the distance does not change, so means it is stationary. So that's right. Because if we have a distance time graph, a horizontal line means the object is at rest. A train moving when y represent the distance of the last station. So if it's a distance time graph and we have a horizontal line, it does not mean it's moving. It means that the object is stationary or at rest. So statement 2 is incorrect. Then the train is stationary if y represent the speed. So if it's a speed time graph, means it has a certain constant speed. So means if it has a constant speed, train is moving. But here it shows the train is stationary. So that's also wrong. And the last one, the train is moving when y represent the speed of a train. Like it shows it has a constant speed, and a constant speed the train is moving. So if it is a distance time graph, and a horizontal line means the object is not moving. But if it is a speed time graph and we have a horizontal line, it means the object is moving and object is moving at a constant speed. So this is object is at rest and this is a moving object. So speed time graph, horizontal line object is moving. Distance time graph, horizontal line means object is not moving. That's why 1 and 4 are the right statements. Is it clear? Question 14.
Yes, sir.
Okay. The diagram shows a speed time graph for a moving object. This is a speed time graph when speed time graph. So what will happen? The speed time graph, the slope represent the acceleration. So if the slope is decreasing, it means the acceleration is decreasing. So this is a decreasing acceleration. If it was a constant speed, like decreasing speed, if it was a decreasing speed, the graph will go down. If it was a constant acceleration, it will be a straight line. If it is a constant speed, it will be a horizontal line. Which row about the orbit of the Earth and the Moon is correct? Approximate time for the Earth to orbit the Sun. So how much time the Earth is taking to completely move around the Sun? So that is 365 days. And the approximate time the Moon take to orbit the Earth, that is 1 month or 30 days. Which statement about the orbits of the comet is correct? So comets, they have elliptical orbit. Like this is representing the sun and we compare the orbit of the comet. So that is elliptical. And sun is not the center of this elliptical orbit. So it has an elliptical orbit and the sun is not at the center. Which row describe the power sources for a stable star? The type of nuclear fusion happen for the stars and what fuses the hydrogen fusion happen. That's why C is the right answer. Question 19, which quantity can be determined using the brightness of a supernova? Supernova, it's an explosion which happen or occur when the high mass star, like a supergiant, explode due to a heavy element fusion, and it give out enormous amount of light, which can be used to detect the distance of those galaxies from us or distance of those stars from us. So the speed at which a galaxy is moving, no, the distance of the galaxy from Earth. So using the light which is emitted from the supernova can be used to find out how far this star is from us. Hubble constant and age of universe. Hubble constant can be used to determine the age of universe. Question 20. The nearest star to the sun is about 4 light years away from the earth. The student makes these three statements about the star. So which statements are correct? Light from the star take about uh, because it's 4 light years away, so it will take 4 years to reach Earth. That's correct. Light from the sun takes 4 years. That is wrong. And star is outside of our galaxy. Our galaxy is 100. Our galaxy is 100,000 light years. So it's 4 light years is shorter than 100,000. So means this star is inside our galaxy, not outside. Because if it was outside our galaxy, then it could take more than 100,000 light years to uh, like it should be the calculated value should be
See,
100 more than 100,000 light years. So that's why C is the right answer. So these are the MCQs which were related to the test.